Assalamu alaikum. Today the topic is EIGRP frame relay. EIGRP is a separate protocol, but in this topic, frame relay with hub and spoke is a very famous part, which normally we have seen in many exams. And the important part is that EIGRP is normally used in routers, but the part is that we can use it as a frame switch also for ourselves. And the important part for that is that it has been used in many different areas to support the network and that we should be connected with each other. So having said that, we will go to the next slide, and here we can see that our objectives for this video or discussion would be that we will be reviewing the basic configuration of EIGRP on a serial interface, okay, and we will be configuring the bandwidth percentage command, okay. We will be understanding how EIGRP works on over frame relay hub and spoke topology, and we will be also using EIGRP in non-broadcast mode also. And with that we will be doing manual summarization also. So like almost 5 tasks we have to do it. Here is a logical diagram which I have just drawn it for myself, okay, just for the exemplary thing. In this we had 3 offices, I mean to say one is headquarter, other sub offices, and these 3 offices are connected on WAN connection, the way we can see it. These are the WAN connections, okay. So now in this case we are putting 4 routers, okay, 1 2 3, and the middle router we are using as a frame relay switch. And I want to tell you that we will be creating loopbacks on these interfaces, on serial interfaces on each router. The only difference would be the subnet, okay. So for you people maybe the difference would be there, but if you are using GNS3 you can go with that. So my advice would be that always draw a network diagram that reflect the topology. So that's the basic part. And here I want to show you one command, show controller serial 0 by 0 by 0, and it will tell you all the hardware details on that, especially clock rate and your interface status also. So in this case we are connecting through hub and spoke frame relay, okay, and company headquarter we are considering as a hub. As I told you that company headquarter would be a hub for us, okay, because through that the communications will occur. And as I told you that it will be have a loopback address interfaces just to test our connections, okay, and we require full connectivity between all departments, okay, and we are using in this topology 3 serial ports. So I'm assuming that you people are aware of those things, okay. You will create those loopbacks on each 3 routers, simply is that, and just changing the subnet of each other, okay. Once you do it, your router would be good to go for the testing. As I have mentioned to you in the previous slide, it would be there, and we will leave the default encapsulation to HDLC on the router. Now having said that, let me describe the part there that EIGRP being able to use 50% of that bandwidth by default. So this is the default behavior of EIGRP. We cannot do anything, it's by default. So bandwidth configuration cannot be changed. Okay, bandwidth percentage would help us. This is the basic part to control the EIGRP bandwidth, otherwise it will choke the bandwidth. On low speed interfaces, bandwidth for EIGRP above the 50% is advisable in order to improve convergence. Okay, because that will help you to converge the full environment when you do show EIGRP routes, so you would see all the details there. So in this case we would have a lot of easiness for convergence. So here we are talking about some encapsulations, like for LAN Ethernet we are using those encapsulation, Ethernet token ring and FDDI. Point-to-point serial interfaces we are using HDLC and point-to-point protocol, and on NBA interfaces we are using frame relay X.25 in ATM, which is non-broadcast multi-access networks. So why we are doing it there? That because EIGRP may be lost in the switched network if you don't use those technologies there. Okay, so for this lab which we have discussed it, there are three basic rules. The traffic that EIGRP is allowed to send on a single virtual circuit, okay, because we have created a loopback, okay, and in a loopback we are considering this as a virtual circuit. VC, it will make a virtual circuit. The total EIGRP traffic for all virtuals cannot exceed the access line speed of the interface. Okay, so we have to be very conscious in this case. The bandwidth allowed for EIGRP on each virtual circuit must be the same in each direction. Okay, so the bandwidth must be the same in each direction. And non-broadcast multiple access interfaces, we can configure it in three ways. One is multi-point configuration, one is point-to-point configuration, and third one is the point-to-point and multi-point. Means to say you will mix all those two things with this one. So for multi-point configuration, what is happening basically that EIGRP will divide the configured bandwidth evenly across each circuit. So how we will take it, like let's suppose we have a T1 access line 56K. Okay, you should configure the bandwidth to 24K, 24K, because if you multiply 4 with that, so 56K will be there. Like you have to equally divide each and everything, and that is the bandwidth percentage that we were discussing in the last slides in which we have discussed it. So if you have a 256, okay, so then you can do it with the 56K, because your values would be changed according to your bandwidth. And slow virtual circuits onto point-to-point subinterface is strongly recommended. Okay, this is the key point that a person network engineer must understand. Point-to-point configuration, where we can use it. These are the allows maximum bandwidth. Okay, since each bandwidth can be configured separately on each interface. Okay, so if we have a 154K, okay, and we have 10 virtual circuits with the capacity of this thing, the bandwidth on each sub interface should be configured to 154. The reason behind is that each sub interface, okay, it will use it in the best capacity. Like total bandwidth for all sub interface cannot exceed the available access line bandwidth. So I hope you people are getting it right. hybrid configuration, point to point and multi-point. So in this case, what is happening that we have a point to point connections also, and we have point to multi-point scenarios also. Like, because if you are seeing these things, okay, so this is point to point, and then it comes multi-point, okay. But once we go to the next slide, we will see it there, that how we can configure those things, okay. Like for the hub router, this is what we have to do it. Okay, 25 means 25k. It will by default take it as a 25k. When you write it 25, so it is equal to 25k. And this is how the bandwidth is configured, okay. And the same thing will goes for the spoke router also, because in spoke router we need to do the same things which we have done in hub router, okay. And there is another scenario which is full mesh, like each router can independently speak with another router. Router A can speak with router C, router D, router B. Router C can speak with router B, router D, and vice versa A. And this is how we will do the configurations. On each part we are doing the same configuration, because actually basically what is happening, that in point to point sub interface, EIGRP will divide the bandwidth entirely across the 3 PVCs. However, there is overly restrictive for the PVC connecting routers A through C, since they have sufficient capacity to handle a lot of more traffic. One way of handling this situation is to convert the traffic to use point-to-point sub-interfaces for all PVCs, as in the example above. Another way which we would require configuration is to break up the network by putting router A through C on a fully meshed point-to-point sub-interface and use a point-to-point sub-interface for connecting to router D, and making all router D's connections to point-to-point sub-interface instead. And here you can see the configurations also. The most important part is that this router 3 with 3 CMFAs is the frame relay switch. How we can configure it? Just put the name of FRS, okay. You have to enable the frame relay switching, okay, and then you try to describe those things, and frame relay interface type we have to discuss, and the type you just mentioned is Cisco. And in the serial 01, in the serial 010, same. So basically once you do it, you can check the connectivity, okay, and you can good to go. I hope so. It's very informative for you people, okay, and I would like to thank you for joining me, and I would try my best to bring more videos for you people. Okay, thank you.